Jumbo, this PowerPoint is looking at how we write ionic compound formulas. There are things you're going to need when you do this, because chemistry, if we don't like to memorize a lot of things, we like to look things up on charts. So you want to have your periodic table, and it should be flipped to the side that says periodic table of ions, and you want to have your table of complex ions handy as well. Now, to start off with, in an ionic compound, what you're doing is you're balancing out charges. You're balancing out the number of electrons transferred from the metal to the non-metal. So when you finish, the total positive charge from all the metal ions will equal the total negative charge from all the non-metal ions. Your whole mission is to balance charges. Now, we could do semi-complicated math that's not very complicated, or we can use arrows. And we are going to use arrows to make life very simple. So here are the steps. You are going to write the symbol and charge of the metal or ammonium. Ammonium is the only positive complex ion on your table of complex ions you have to worry about. Then you write the symbol and the charge of the non-metal or negative complex ions. Most complex ions run into are negative. So those two steps are really easy. Just look them up, write them down. Step 3, you are going to crisscross those charges. That's where you're going to use some arrows. And charges are written up top. And when we crisscross, they become subscripts. And once we've written subscripts, we don't care about charges anymore. We do not write charges at all. And step 4, if possible, we reduce the subscripts to lowest whole number ratio. So we're going to do a bunch of examples here. Have those two sheets handy. So we look at calcium chloride. And there's our Ca2 plus and our Cl1 minus. So that was step 1. That was our charge and symbol on the metal and the charge and symbol on non-metal. Now my arrows aren't too good, but step 3 says crisscross. So this 1 is going to come down here and become a subscript. Whoa, what happened there? And this 2 is going to come down here. And now we're ready to write out a formula. CaCl2, and we're done. Notice I didn't bother writing out the 1. Chemists like to avoid writing the number 1 if they can. So if you just see a Ca, that's it. That tells me there's 1 calcium. And this tells me there's 2 chlorine atoms. Multivalent metal, and I'll have to show you in another video what multivalent means. But on your periodic table, when you look at the side that says periodic table of ions, if you look at something like iron, it will say +2 or +3. Copper, it will say +1 or +2. Gold, it will say +1 or +3. So in other words, when you see a symbol for a metal that appears twice in the box on the ion side, that means it's multivalent. The multivalent just means it can have more than one charge. And that means somehow when we're going to a formula, I have to tell you what that charge is. So iron 111, or III, iron 3 oxide. So I write down the symbol and the charge. I guess I should have chosen a different color. That's supposed to be an arrow. So that 3 tells me I'm looking at a 3 plus charge. I had a choice of 2 plus or 3 plus. Since it said III, it's got to be the 3 plus. Now my arrows come in for crisscrossing. Boom and boom. And I get Fe2O3. Now I cannot divide this by 2. Yeah, I could get down to 1 iron, but that would give me 1.5 oxygens, and I cannot have half an atom. So Fe2O3, I am done. That one's perfect. Now we look at tin 4 sulfide. IV means 4. So that means I'm not using the tin 2 plus, I'm using the 4. Oh boy, the arrows came in first. That's not good. So here's my SN 4 plus, because that was a 4. And that 4 is going to go down here. Sulfide is always 2 minus, so that 2 came down here. Now I go SN2S4. And it's right and it's wrong. It's the right ratio, but it hasn't been reduced. So I have a 2 here and a 4 there. I'm going to divide both of these things by 2. And I end up with the proper answer of SNS2. And again, I don't write a 1 down there. If you write a 1 down there, it is wrong. Now we're looking at ones with complex ions. It doesn't mean both ions will be complex. They could be, but it means at least one of them's complex. Anytime you see an ending ate or ite, that's definitely going to be a complex ion. So aluminum, I know, is on the periodic table, so I'm going to write its symbol in charge. Chlorate, O-A-T-E, it's got to be a complex ion. And this is why spelling really matters. You got to read things right or it's wrong. So we have Al3 plus, and you see ClO3 1 minus. If you wrote down ClO2 1 minus for chloride, it's wrong. You are not writing the formula for the right thing. Really important to have these brackets here, because what we're saying is these 4 atoms, the 1 chlorine, 3 oxygen, share 1 extra electron. They are working as a team. So we've got to put the brackets in. Now we do our crisscross. And that means this 1 comes down here. We're not going to write the 1, and the 3 is going to come down here, and it will go outside the brackets. And that is the correct formula for aluminum chlorate. Again, stuff you probably saw last year. You may be refreshing your memory. You should find it easy. More with complex ions. So we look up ammonium, the only positive complex ion, and we look up thiosulfate, which is a negative complex ion. This one turns out to have a lot going on. So here's our 1 plus. It's going to be coming down here. And here's our 2 minus, and that 2 is going to come down there. Remember, when we write subscripts, we don't put any pluses or minuses. So we do our crisscross. And you might think that is the right answer, but there's one more step we have to do. If you end up with a 1 outside the brackets, you get rid of the 1 and you get rid of the brackets. The NH42 is going to stay the same, but the S2O3 is going to shed its brackets. And there we have the correct answer for ammonium thiosulfate with the brackets gone around the S2O3.